Good afternoon, dear colleagues. Today we have a defense of the dissertation by Rakhym Akmaral on the topic sorbents based on aluminosilicate, raw materials for heavy metal ions, bisphenol A, and propanol extraction from aqueous solutions. Specialty 6D060600, chemistry. Scientific supervisor Silhanova Guzia Mangidivna, Doctor of Chemical Sciences, Professor of Department of Physical Chemistry, Catalysis and Petrochemistry, Al-Farabi Kazakh National University. Mastai Itzhak, PhD, Professor of Institute of Nanotechnology and Department of Chemistry, Bar Ilan University, Ramat Gan, Israel. The dissertation was performed at the Department of Physical Chemistry, Catalysis and Petrochemistry of the Al-Farabi Kazakh National University. Official reviews by Menov Aljan Duldasovich, PhD, Associated Professor, Senior Research of Institute of Physics and Technology, Satpayev University, Almaty, Kazakhstan. Turmanov Rakhymjan Ahmedkhanovich, PhD, Senior Research of Engineering Laboratory of Korkhta Kızılarda University, Kızılarda, Kazakhstan. Temporary members of the Dissertation Council, Marjan Sitovna Kalmakhanova, PhD, Associated Professor, Dulati Taras University, Head Department of Chemistry and Chemical Technology, Taras, Kazakhstan. Stavros Palopoulos, PhD, Full Professor, Department Chair of Chemical and Materials Engineering, School of Engineering and Digital Sciences, Nazarbayev University, Astana, Kazakhstan. Helder Gomez, PhD, Associated Professor, Polytechnic Institute of Braganza, Portugal. The floor is given to the Scientific Secretary, Professor Bulat Uralbekov, to present the documents available in the applicant's personal file.
Thank you, Chairperson. Let me briefly introduce all the documents we have here in the Dissertation Council and also about applicant. Applicant born in 1994, Rakhym Akmaral Bakhtjan Kızı, first her undergraduate studies at Al-Farabi Kazakh National University from 2012 to 2016 at Faculty of Chemistry and Chemical Technology, majoring chemistry. In 2016, she enrolled in master program at the same university, specializing chemistry, and successfully completed her study in 2018. From September 2018 to May 2021, Rakhym Akmaral Bakhtjan Kızı pursued her PhD at the Faculty of Chemistry and Chemical Technology of Farabi University, majoring chemistry. The topic of her thesis and her advisors were approved by Academic Council of our university on December 4, 2023. Rakhym Akmaral personal file includes copies of her bachelor and master diplomas, list and copies of her publications, positive recommendation letters from her scientific advisors, both local and foreign, and the protocol of enlarged meeting of the department, and all other requirement documents in accordance with regulation of the Committee of the Republic of Kazakhstan. And as a part of her dissertation research, the doctoral candidate published 14 works, including one paper in Q1 journal, Microporous and Mesoporous Materials, and one paper in Q4 journal, indexed in Emerging Source Citation Index of Web of Science, and 4 papers recommended by the Committee of Quality Assurance and Science and Higher Education. One article in Proceedings journal, included in the Web of Science and Scopus databases, and also several abstracts presented in international conferences. On April 23, 2025, Rakhym Akmaral Bakhtjan Kızı dissertation was discussed at the expanded meeting of the Department of Physical Chemistry, Catalysis and Petrochemistry at Faculty of Chemistry and Chemical Technology. And to this meeting, 36 participants attended, The first reviewer, the professor and director of Institute of Combustion Problem, Rashid Kazimовich Nadirov. And the second reviewer was a PhD senior lecturer at the Department of Analytical and Colloidal Chemistry and Rare Elements Technology, acting director of Center of Physico-Chemical Method of Research and Analysis, Rustam Risatович Tokpayev. And all questions and comments raised by reviewers received responses, and as a result, the seminar anonymously recommended dissertation for further defense. This was approved by protocol number 24, dated by May 6, 2025, and approved by a board member and vice rector for research and innovation of Kazakh National University, Margulan Kasenovich Ibrahimov. And on October 8 and October 10, 2025, by protocol number 44 and 45, Dissertation Council scheduled the defense date and appointed reviewers, and also the Dissertation Council designated the external council temporary council members. I also want to give you some information about the procedure. Today, Dissertation Council conduct at the end of the procedure, the Dissertation Council conducts secret ballot to make one of the following decision. The first one is award the degree of Doctor of Philosophy. The second one is to send the dissertation for revision. The third one is recommend a repeated defense of the dissertation. And also the final one is refuse awarding of the PhD of the Doctor of Philosophy. So if the dissertation does not fully comply, dissertation is sent for revision if contains minor remarks that do not alter the essence of the work. If the thesis or dissertation does not fully comply with clause 4 and clause 6 of the degree awarding rules, and also partially adheres to the principle, except the academic integrity outlined in the clause 5, it's recommended for a repeated defense. So these, if there is a violation of academic integrity and non-compliance with principle of scientific novelty, internal consistency and reliability, a decision to refuse degree is made. Is also if the candidate was not proven the provision of the thesis. The official reviewers also participate in the secret ballot, and their votes have the same weight as the votes of Dissertation Council members. So that's why please stay until the end of procedure. Thank you.
Thank you. Dear colleagues, are there any questions for the scientific secretary? Do you have any questions to PhD candidate? No? Okay. The floor is given to the applicant to present the content of the dissertation. Akmaral, you have 20 minutes. Please.
Good afternoon, dear dissertation committee members and dear colleagues. I am pleased to present my dissertation titled Sorbents based on aluminum silicate raw materials for heavy metal ions, bisphenol A, and propranolol extraction from aqueous solutions. Okay. Water pollution remains one of the most urgent environmental problems of our time. And as coated solutions, aluminosilicate adsorbents have proven their efficiency for heavy metal cations adsorption. However, they have limited adsorption of anions and organic substances. And chemical modification with surfactants enables alteration surface properties of aluminosilicate, resulting in development of multifunctional adsorbents, which are more effective in sustainable water purification. And the purpose of this work is obtaining novel, efficient adsorbents based on natural aluminosilicate raw materials, in particular zeolite and chamois clay, and establishing the physicochemical regularities of heavy metal ions, bisphenol A, and propranolol adsorption from aqueous solutions.
Презентацию с первого слайда поставьте. Презентация стоит все время на 5-м слайде, по-моему, да? Или на 3-м. Не перелистывается.
А теперь видно?
Да, теперь видно первый слайд. Да.
Ага.
Can you make
Okay.
it full screen, please? If possible.
Нет, можете полный экран сделать? Да. А может быть, в Zoom не видно, да?
So just a moment, few technical,
Yeah, sorry.
technical problems.
Канара, может, вы экран будете полностью показывать? Тогда будет. Да.
Все хорошо видно.
Now
Весь
is
экран.
Ага. Okay, should I continue or start over? Continue. Okay. So key research tasks of the thesis are shown on this slide. And as object of the study, two representative classes of aluminosilicates, natural zeolite from Shankanai deposit and chamois clay were selected. And to modify these materials, two types of surfactants, anionic sodium lauryl sulfate and cationic didodecyl dimethyl ammonium bromide were chosen. In the course of this work, adsorbents based on two types of raw materials, zeolite and clay, undergone three types of pretreatment. First series include unmodified objects, second series modified with sodium chloride, and third activated with hydrochloric acid. These three series were modified with two types of surfactants, cationic DDAB and anionic SLES, and obtained adsorbents were employed in adsorption experiments. On the next slide, flowchart diagrams for detailed adsorption synthesis procedure are shown. The first diagram is for pre-treatment stage, where three series of adsorbents were obtained. And the second flowchart is for surfactant modification process. As a result, we obtained 12 types of adsorbents. Main revisions set for the defense are shown in this slide, and they will be discussed in detail throughout the presentation. As the first step of study, physicochemical characterization of both initial and modified materials with different analytical instrumental methods was done. Here you can see XRD patterns of the studied materials. We can see that zeolite mainly consists of clean ptylalite and contains some anorthite and quartz phases, and chamois clay consists of mullite with some kaolinite and quartz. On the next slide, textural properties of studied adsorbents and cation exchange capacities are shown. And this data support provision number 1, which says that treatment with sodium plus ions increases the cation exchange capacity of zeolite and chamois clay. Whereas acid treatment decreases their cation exchange capacity, but enhances their specific surface area. Okay. At the next step, heavy metal ions adsorption was done. Zeolite or clay modified with anionic surfactant were used for heavy metal cations adsorption, such as lead, cadmium, and strontium, and modified with cationic surfactant for adsorption of heavy metal anions, such as dichromate and permanganate. In table 3, you can see the results, we can see that initial zeolite and clay are effective for lead ions. But they are less effective in case of cadmium and strontium. But modification with SLS improves extraction degrees, for example, from 73.4% till 97% for cadmium and 49.5 to 92.1% for strontium. And the best forms of adsorbents are original zeolite and clay for lead ions, zeolite and clay modified with SLS for cadmium, and zeolite modified with SLS for strontium. On the next slide, the scheme of interaction of zeolite or clay and SLS is shown. Here we can see two interaction sites. The first represented by ion exchange interaction between SLS and the OH groups that are present on the surface in the pores and channels of the material. And second is electrostatic attraction between exchangeable cations that are also present in the zeolite and clay channels and pores with anionic head of SLS. This data can be supported by FTIR spectra and subsequent increase of concentration of SLS leads to formation of a bilayer and when interacting with metal cations, there are also two adsorption sites. The first is electrostatic attraction of the positively charged metal cation and this less sulfur group. And the second is the formation of donor-acceptor bond between the metal ion and free electron pair of oxygen of this less toxic group. On the next step, adsorption of heavy metal cations was done, and here we can see that initial materials very poorly adsorb these substances, and direct modification with DDB slightly increases these numbers. But when we use first acid activated zeolite or clay with further modification with DDB, we can reach higher extraction degrees, reaching, for example, 75 or 80%. And best forms of this can be explained by the fact that acid activation leads to increase of silicon aluminum ratio, making the surface more hydrophobic, which probably leads to better interaction and better coverage of the surface with surfactant. And best form of adsorbents are zeolite or clay pretreated with acid with further modification with DDB. On the next slide, you can also see the scheme of zeolite and clay with DDB interaction. Here we also have two interaction sites, but they are like vice versa if comparing with SLS. So electrostatic attraction with OH groups and ion exchange with exchangeable cations. And also increasing concentration of DDB leads to formation of bilayer and recharging the surface, which makes it able to adsorb negatively charged anions of dichromate and permanganate. And this data support provision number 2, which says that modification with anionic surfactant SLS increases absorption activity of zeolite and chamotte clay due to surface functionalization. Modification with the cationic surfactant DDB enables effective absorption of anorganic anions such as dichromate and permanganate due to the formation of a positive surface charge. The next key task was determination of adsorption mechanisms, which describes how adsorbates interact with adsorbent. There are 3 main types of adsorption mechanisms, physisorption, chemisorption, and ion exchange, and we would like to emphasize that this is a very complex task, which includes several steps of research. And for this complex task, model system Shamat clay and lead ions was chosen because it is the simplest system in our study, and effect of external factors was studied, and the results are shown on this slide. But we would like to pay your attention for modeling of adsorption isotherms. We used several models such as Langmuir, Freundlich, Temkin, Dubinin, Radushkevich, Sieb, Stott, and others. And on the next slide, you can see the adsorption, experimental adsorption isotherm, which is typical Langmuir isotherm, but using Todd model minimizes errors, and let's obtain more accurate equation to model the experimental data. On the next slide, application of reaction kinetic orders are shown, order models are shown, and here we can see that pseudo-second order model best describes the process, and the application of pseudo-nth order model lets like more accurately determine the order of the process, which is also close to 2 in most cases. On the next slide, application of diffusion kinetic models is shown. We used 2 types of intraparticle diffusion models, equations, the first Weber-Morris and Dumwalt-Wagner, and also applied hybrid chemisorption diffusion model. And the application of Weber-Morris model, we can see here that plot consists of 2 straight lines, which indicates that mass transfer process includes more than 1 step, and it does not pass through the origin. So it is also a confirmation of several steps of mass transfer. And high parameter C values indicate of high amount of surface adsorption. Dumwalt-Wagner model results indicate about the film diffusion is rate controlling step, and the application of chemisorption diffusion model indicates of ion exchange process. That ion exchange is a very rapid process, so diffusion is a rate controlling step. And summarizing all diffusion models results, we can assume that diffusion is rate controlling step here. Here you can see adsorption thermodynamic calculations. In negative delta G values indicate that process is spontaneous. Negative delta H values indicate that it is exothermic and adsorption is favorable. And little absolute values of delta H indicate that it is a physisorption. And positive delta S values indicate about active ion exchange processes. So when summarizing all obtained results, mechanism of interaction of clay with lead consists of 3 main types of interaction. The first is surface layer adsorption of silicon OH4 tetrahedron layer with lead ions, which results in a lengthening COC, CO aluminum bonds, which is confirmed by FTIR and Raman spectroscopy results, and the diffusion kinetic models, Weber-Morris model. The second is inner layer adsorption of aluminum 6 octahedral layer of clay with lead. Here, this is also confirmed by FTIR and Raman spectroscopy and thermodynamic calculations. And the third is ion exchange with exchangeable metal cations, both in the pores and on the surface of clay, which is confirmed by chemisorption diffusion model and thermodynamic calculations. Next slide, please. Yeah. So during the determination of mechanism, 2 main types of interaction, physisorption and ion exchange, occurred, and we wanted to try to estimate which one is dominating. So we tried to make such experiments where we altered the clay properties So sodium treatment increased cation exchange capacity, making the clay more selective for ion exchange. Acid treatment increased specific surface, making clay more selective for physisorption. And the results can be seen in the table. So we can see that acid treatment significantly decreases absorption degrees from almost 100% till 25%. So that it tells that ion exchange is the dominating mechanism. And we propose to use such approach as method of rapid identification of dominant interaction. But however, there are some limitations because it is applicable for only specific aluminum silicates. It doesn't provide data about chemisorption and can be used in complex with other methods. Yeah. At the next step, adsorption of organic pollutants was done. As model organic pollutants, we chose bisphenol A and propranolol because of their distinct chemical nature, because bisphenol has anionic sites, and propranolol has both cationic and anionic sites. And here we can see that modification with DDEB is effective in that case. And for further studies, systems based on zeolite modified with DTP were chosen. And the choice of zeolite in this case was also because we wanted to try the proposed before method for other system. And on the next slide, you can see application of this method on bisphenol A adsorption. Here we can see that modification with sodium and acid decreases extraction of bisphenol, and this indicates that neither ion exchange nor physisorption are in the mechanism of adsorption, but interaction includes hydrophobic interaction, electrostatic attraction, and chemisorption. Next, here are propranolol adsorption results, and this row of adsorption efficiency increases in parallel with the surface area increase, which indicates that physisorption is one of the interaction types, which also include hydrophobic interaction, electrostatic attraction, and chemisorption. This data support provision number 3, which says that lead ion sorption on chamois clay occurs mainly through ion exchange with some contribution from physical adsorption in pores. For bisphenol A and propranolol, enhanced adsorption on DDB modified zeolite is associated with surface recharging and strengthened hydrophobic interactions. The adsorption mechanism involves chemisorption and electrostatic attraction for both bisphenol A and propranolol, as well as physisorption in the case of propranolol. On this slide is shown the practical significance of this work. So during this work, we studied adsorption of several groups of pollutants, and we recommend that zeolite or clay can be used for adsorption of surfactant, and metal cations. After adsorption of surfactant, they can extract metal anions and organic anions. And after metal anions adsorption, again, metal cations. And such schematic diagrams of multi-stage sequential adsorption are shown on the next slide. The first for after adsorption of DDB, and the second after adsorption of SLS. So to conclude, during this work, adsorbents modified on zeolite and chamois clay based on zeolite and chamois clay modified with two types of surfactants, DDB and SLS, were obtained. And SLS modification increased adsorption of heavy metal cations, DDB modification of organic substances and heavy metal anions. And mechanisms of adsorption were identified. And lead ions adsorption on chamois clay mainly consist of ion exchange. The obtained adsorbents demonstrated potential for selective pollutant removal and sequential application in multi-stage adsorption. These work results were published as 3 articles in journals in Scopus and Web of Science, 4 articles in CQIS journals, and 7 abstracts in international conferences. And also this work was done in the framework of 2 state funds. and certain research results were obtained thanks to laboratories in Sweden, Romania, and Israel. Thank you for your attention.
Thank you, Akmaral. The presentation is complete. Dear colleagues, are there any questions to PhD candidate? Dear colleagues,
Hello, is there an order to place questions?
Yes, yes.
yeah.
No order, you can ask. If you have questions, you can ask.
Okay. Okay, let me start. Akmaral, congratulations.
Thank you.
It's not easy, to reach this point, and I saw that you made a lot of work. Okay, you published too. So I have some simple questions for you. First of all, I saw your results. Okay, and let me check my notes. In some cases, you achieved 99% removal efficiency for specific contaminants. So I would like to ask you, what do you think, how this efficiency would change in a more realistic environment, in a real wastewater with competing ions or organic matter or variable pH? Could your results be extended? What do you think?
Thank you very much for your congratulations and for very interesting questions. Yes, sure. Unfortunately, we didn't study the multi-component adsorption because the main focus of this study was in obtaining fundamental results such as mechanisms which require single clean solutions to make to have more accurate results. But I think that in real multi-component system, of course, there would be some let's say, if it's correct in English, rivalry between different ions.
Yes, of course.
I think that efficiency would be less. Yeah.
Okay, maybe this is a recommendation, for future work to extend the current study. And let me ask you something else also for me to understand, you, as I saw also from your abstract, you made, but very quickly a reference today, you proposed a new method to separate the contribution of different mechanisms, yes? Can you describe it in simple terms, how we can do it conceptually? If we can maybe generalize this method, because you say this is a new one, and how you validated this method?
Thank you very much. Yeah, this method has some potential, yes, to be developed, and we are planning on doing it.
Just describe the steps of how you implement this.
First, you should take aluminum silicate material, and you modify it with sodium chloride or any like sodium ions to increase its cation exchange capacity, and modify with acid to increase its surface area. So you obtain 3 types of aluminum silicate. Actually, it was on the slide. Renata, can you please open? Yeah. Then you perform adsorption experiments, and then там, где был метод. Ниже. Еще. Ага, вот 21 слайд. Can you see slide 21?
Yes.
So, yeah, at the bottom of the slide, the algorithm of application of this method is shown. We can see again.
Okay.
Yeah, so you prepare 3 types of aluminum silicates. You determine the cation exchange capacity surface area, make adsorption experiments, and analyze the results. So if surface property, like enhanced surface area shows better results, then physisorption is the main mechanism. But if increased cation exchange capacity shows better results, so we can say that ion exchange is better mechanism. So we don't say that like there is no physisorption at all. Of course, it is complex system which involves different types of interaction. But we can say that ion exchange is more favorable or like puts more impact in the mechanism. So we can try it on other systems. Of course, to validate, we try to validate this method on the systems in this work, like based on zeolite materials, based on zeolite modified with DDB on adsorption of organic pollutants. And for example, the results showed that bisphenol adsorption does not involve both ion exchange and physisorption, but in case of propranolol, using this method, we could assume that physisorption is one of the mechanisms because the efficiency was increased in parallel with surface area increase. Of course, to validate and make it like a real common method to use, we should make more experiments on different systems. And we are trying to work on it further.
Okay, and one last question to allow the colleagues, to proceed. I saw in your charts that you, in general, reported adsorption capacities around 1 to 8 milligrams per gram. Okay, in some cases maybe a bit higher. And there are, synthetic materials that achieve, allow me to say, exotic adsorption capacities, So, can you comment on this? I mean, the importance of your work against synthetic materials that they exhibit very high adsorption capacities.
Yes, sure. Natural materials cannot concur with synthetic materials, but they have some advantages because synthetic materials mostly expensive, but natural silicates are more affordable. And also, to be honest, the main point of this dissertation was just to prove that aluminum silicate, which do not usually adsorb anions or organic pollutants, with help of surfactants, can do it. So we can apply these results for synthetic materials, and of course, they would have like huge practical use. So I think that these results are also important and make impact to theoretical knowledge in general.
I agree with you. Do not underestimate your work, because recently I was in Oskiemen, in the gold mining site, where they have huge values of this kind of metals. And actually, I don't see how any of these synthetic materials can be used there. And materials of local relevance, especially like the zeolite that you studied, are very important in environmental engineering. Okay. Thanks a lot, Akmaral.
Thank you very much for interesting question.
If I can now make my questions, I would follow Professor Stravo's intervention. Akmaral, congratulations once again. You did a very interesting work aiming at exploring low-cost natural zeolites and clays as adsorbent for different classes of contaminants. The work was carried out taking into consideration fundamental understanding of the mechanisms. You wanted to understand the mechanisms involved in these adsorption processes, and to do that, you supported by a thorough characterization work of the studied materials. You include modeling with the isotherms, with kinetic results, and you interpreted the results obtained. So it's work, and the document is very well written and with clear conclusions obtained. I have some questions more like general about the goals. So I understood that was a high interest in using these adsorbents based on aluminosilicate raw materials, local materials. I understood affordable, low-cost materials. I would like to ask, so Professor Stravos compared with synthetic materials. I'm asking about, for example, comparing with low-cost materials based on biomass adsorbents like activated carbons or biochars. why the specific interest in aluminosilicate raw materials and not, for example, these other alternative wastes that also exists in Kazakhstan?
Thank you very much for your question. Yeah, sure. Activated carbons also have very specific surface areas, and they are also well, like widely studied in such processes. But if I'm correct, as I understand, they have less selectivity in adsorption processes, and they also need modification. Interest in aluminosilicate materials was actually I never thought about it. I started this work in bachelor's degree and started working with clay, and just continued in master's and PhD works, and like I thought that it would be better not to distract the attention to like go deeper with the same materials. And of course, I agree that activated carbons biomass are also very interesting sphere. But however, I cannot like
I wanted
study
to understand if it is
Yeah.
really very
Okay.
fundamental work, or if you aim also to some exploitation of your results, if you aim to some commercial exploitation of these results and materials, if you have these in your long-term objectives, let's say.
In long-term option, actually, I think that these materials might have interest in selective removal of or selective adsorption of some, for example, substances in hydrometallurgy processes, because usually there are polymetallic ores, and they usually leached with acid, and the production solutions contain like they are multi-component systems, and the macro components are usually separated by other methods such as extraction or precipitation. But however, some micro components can still be left in production solutions, and here selective adsorption can be like the choice.
Okay, I agree also with the multi-component adsorption should be studied, and with also real matrices, and but this is for future. I would like also to understand why you choose specifically bisphenol A and propanolol for your studies. For example, asking if these compounds are found in waters of Kazakhstan, or if you have other reasons behind.
Actually, I was not focusing only on wastewater treatment. I was focusing on like adsorption and what can it make, yeah? I was really curious, like what if we try surfactant modified for different groups of organics? When I started this work there, at that point, it was very popular in literature that it was applied for phenol removal. When I studied environmental bulletin of Kazakhstan, I found that in most of the water bodies, phenol compounds were exceeding MACs. I chose bisphenol A because it is like very abundant, because it comes with plastic, and plastic pollution is like everywhere now. And choice of propranolol was because these systems can also be applied in drug delivery systems. Propranolol is a drug for curing heart diseases. I tried like to study its adsorption. Like, is it possible to apply this materials maybe further in drug? And we are actually working in this direction. We applied for grant fund, and I hope we will win and continue this research. Thank you.
Okay, thank you. One question more. In your thesis, you titled the part where you did the study with the lead to make the study of the mechanism. You titled the section as optimization of the conditions for adsorption. Lead was the most easy to adsorb species. So why you choose lead and not, for example, cadmium or strontium to make this optimization, if you want to use the word optimization, or if it is really just to understand the mechanisms behind, if the conclusions that you gathered for lead also applies for the other species, because the other species are more difficult to absorb than lead. So if we can, let's say, conclude that the mechanisms are that for all species that you study.
Thank you very much. It's also a very interesting question. Actually, like main focus, because I'm a physical chemist, I guess main focus was on fundamental knowledge mechanisms. But if I studied literature, like of last 10 years, mostly, evaluating mechanism ended like with just, it is Langmuir, it is pseudo second order, it is with absorption, and they don't provide the detailed information. But when we study papers, like more recent papers, now it is very interesting to study detailed mechanism, but it is a very complex task. And also I have natural materials which are also complex, and the systems I studied like were complex, and I chose the simplest system, chamois clay and lead, just to try to identify mechanism. And of course, further with the knowledge that I have now, I will be able to try study more complex systems. Yeah.
Okay, just one last question, if you allow me. I'm a chemical engineering, so my question is very like practical, not so fundamental. I would like to understand from your side what to do with the adsorbents after its saturation. Even you made an interesting part in your work trying to reuse them after you adsorbed, for example, surfactants, then you used to adsorb heavy metals, cationic heavy metals, and then anionic. I found it interesting, but in real systems, they are, like we talked before, multi-component systems, so maybe the applicability of this proposal is difficult. So imagine you have your adsorbents saturated, or what to do with them? What is the plan, let's say?
Thank you very much. Yes, there are like several ways to go. The first is to make a desorption and use them again. We tried to study desorption in this work for lead ions, but the desorption degrees reached like less than 5%, and we made conclusions that we should use like more strong desorbing agents, and it would use a lot of water, so maybe it's not very good in practical way. So that's why we tried to study like sequential adsorption processes. For example, after initial material is used for surfactants removal, it can be it's like almost the same as modified. It becomes like modified adsorbent, and you can use it for for other material, for example, anions or organic pollutants. And we tried one experiment after adsorption of, so zeolite adsorbed DDB, for example, then adsorbed dichromate, and after that we adsorbed lead ions. And the results were quite promising. So I can think that it can be used like that.
Yeah, it was interesting, that part. Many thanks. I concluded my intervention, and again, congratulations for your work.
Thank you very much.
Hello, everyone. Can I ask questions? Can you hear me?
Yes, please.
Okay, thank you. Okay, thank you, Akmaral. First of all, yeah, congratulations. It was a huge job and big work you did. However, I have several questions. If we start from the slide number 8, could you please open the slide number 8?
Renata, number 8, please. 8.
Or, for example, let's say start from 6. about your provisions. Provision number 2, right? You say about the cadmium removal, strontium removal, and so on, chromium. But all of these results is here, but I couldn't find these results in the thesis. I mean, there is no any graphs, kinetic, isotherm graphs, any calculations. Just you present this in general. How can you?
Yes, thank you very much for such a detailed interest in my work. Yes, there is an explanation because I'm working in this topic from bachelor's degree. These results were already defended in bachelor's, master's thesis. So in order to avoid self-plagiarism, we decided not to include all these details in this thesis, but to use as a summary table and then go further studying interpreting mechanisms and other results. However, this data can be found in publications, and the references are given in the thesis.
Okay, maybe I'm wrong, but if you did this results experiment during your master or bachelor studies, it means you didn't do it during your PhD studies, right?
No, I mean the experiments like absorptions themselves, but identification of mechanisms was done in this thesis. And this provision gives information not only about the removal efficiencies, but also like why it happens, about mechanisms. So I thought that it would be appropriate to use them here.
Okay, but still, you presented these data results, but didn't present, let's say, the proof as a table, as a graphs, for example, and so on. That's why I raised these questions, because yes, I see these numbers, percentage, and so on, but no any graph, no any pie chart or any actual results in form of the graphs. But you present this as a one main provision, let's say. Okay. I understand, yes, that you published in the papers and so on, but then if you present this as a result, I thought that you need to present this as a results in the thesis in general. Even it's not self-plagiarism because you already published all of these results with the lead, also with the EPA, right? But you present all of this in the thesis, but didn't present this chromium and so on. All right. The next question is regarding slide number 8, table 2. Cation exchange capacity, the total number of the pure zeolite and the sodium zeolite, 616, 624, plus minus almost 17. The difference is not very big, right? It means if we take the, let's say, average or the number is the same, then why some of the materials have better ion exchange capacity if
Thank
the
you very
total
much.
number of cells is the same?
Yes, thank you very much. Yes, at first sight, total cation exchange capacities are very similar, but here we should look at it in detail, especially on cation exchange capacity by sodium, because sodium ions are like most active ions in ion exchange processes. So the cation exchange capacity by sodium ions increases from 116 to 230, which has statistical significance. Yeah, it is not in the standard deviation range. And also increased absorption capacities in some cases also prove that cation exchange capacities is like better. And also I've seen such cases in literature. So I think that it can be an explanation.
Okay, but still, but you said that ion exchange not only goes by sodium, right? Or also by the calcium in some of your next slides, I guess, for example, slide number 10, you also said that not only sodium, but also calcium plays a role in the ion exchange or in other interactions. It means both of them are active, sodium and calcium, right?
No, yes.
No?
Actually, I showed calcium as an example just to make this scheme simpler and more understandable. So it's not exactly calcium. Maybe I should have shown it like metal in general, so not to make confusions. But here I meant not only calcium, but all of these
Yes, I
metals.
see. For example, B. You see here B. Exchange cation, sodium, potassium, calcium are present in zeolite channels and clay and act as a source of X positive charge.
Mhm.
It means all of these cations are ion exchangers, right?
Yes. We show cation exchange capacity in that way because it is common way to present it in literature. Only these 4 ions are usually considered. That's why we measured the concentration of these ions during termination. But however, there are data in literature that sodium ions are most reactive in ion exchange process. So we pay more attention for sodium cation exchange capacity.
Okay. Okay. In this slide, number 10, the FTIR spectrum, SLES modification. I see the pattern of the SLES and the, for example, pure clay or zeolite. And there is no any peaks of the SLES on the clay plus SLES, for example, right? Why there is no any similar peaks that correspond to the SLES? We couldn't find it in the composite.
Yeah, thank you very much. Actually, these are all questions from your review. Is it okay to answer now? Yeah, okay. Thank you. It can be explained by that fact that we used very small concentrations of surfactants in millimolar range, and probably during FTIR analysis, the peaks have like very low intensities. But however, we can see some differences, for example, in OH group peaks, which can confirm that there is some interaction with OH groups. And also the proof of modification can be that adsorption capacity increased. So it should happen due to some reasons. So we can say that it can be like additional proof that modification was successful.
If you say that the number of the modification engine, or let's say of modification agent is very low, then why it gives so high addition to the absorption capacity? And also, what was the percentage of your modification agent used or that was on the surface? I mean, what percent or percentage of the modification agent that was on this? Let's see, what's the number of the modification agent?
Actually, I didn't calculate exactly percent. Here we used number of critical mid-cell concentrations of surfactant because it's usually applied in literature when studying surfactant modified zeolites or clays. So it was 20 critical mid-cell concentrations. So I don't actually remember exact numbers, but it was like 0.5 millimole of surfactant, something in this range. It is very small concentration comparing to zeolite. And when we worked with other materials, not in this thesis, but in general, for example, clay modified with polymer materials, We also had similar results that direct peaks of organic substance were not visible, like exact peaks. But however, we study some changes in CO, aluminum peaks changes, which can also can be as like not direct measurement of modification, and it's also can be seen in literature, such approach.
Okay, but that's the point, that there is no any direct confirmation that you have such agents on your material. Okay, the next slide, 11. See here in the table, you said that the time of your experiment, kinetic experiment, it is 3 hours, right?
Yes.
How did you know that this time is enough for reach equilibrium or maximum absorption? Because I couldn't find the kinetic graph in your thesis.
So here is the same problem with your first question about like, because you couldn't find details. So they were done in previous studies and in publications. So because we included only summary table, this data also given like just a summary, but 3 hours here is like time sufficient to reach equilibrium for given results in this table, because it is different for each metal, but in 3 hours equilibrium is reached.
Yeah, because I know from the literature and from my college studies that zeolites reach the equilibrium in days, at least 1-2 days, not so fast. I don't know why you have such.
Probably
you have a very fast material.
Yeah, sorry. Yeah, probably it also depends on concentration, because we used like low concentrations, quite low concentrations. Probably that's why it was reached like faster.
Since you didn't reach the maximum, you took the very small concentration. That's why. But if it's you see the cadmium or strontium removal, it's only 50%, right? Maybe if you leave it for 1 day, maybe it will be higher. No?
No, we did experiments. We left for 1 day, for 3 days, and no changes were observed.
Okay.
Thank you.
Okay. Reaction models, please. 17. Slide number. Table number 5. It's very interesting results. And the first question: why you make put the models for different concentrations? First of all. Second, I see some R² results is 1.
Yes.
How it's
Yes.
possible to have R² is 1?
Yeah, so might seem confusing, but because we used a program, actual Python code to calculate this data, it gave us R² equal to 1, and it happens when the residual errors are very low, and the program automatically gives number 1. So we put this data in the way as it was given by the program. And also regarding why we studied concentrations, yeah, it's not very common for kinetics, but because these are like pseudo order reactions from physical chemistry, we know that pseudo order means that you like design experiment in that way to make it see the first or see the second, see the third order, etc. So I wanted to see if like changing concentration would affect the order of reaction. It was interesting. And yeah, because it's not commonly studying, it may look like strange, but it just was my curiosity, so I tried. Yeah.
It's very strange because your first order results, Q experimental and Q calculated, is absolutely the same. It cannot be the same. How you can prove that your models are correct? I mean, the Python, this program calculates your models in the right way. Because I have some experience in this also models, and I never had R square 1. It's unbelievable to have the 1.
Yes, I also was like surprised when I got these results, but I tried like several times and obtained several results, or the same results. So I decided that it would be right to give it as the program calculated in that way.
Still, it's very interesting to have such very close results. So that's why I raised these questions, because I couldn't find any of them.
Yeah, sure.
Let's say fitting graphs and so on. So the first or the second order. No, there is can be modeling graphs. If it's non-linear, you can put that together. But in your case, it's absolutely the same as experimental. How many replicates did you do for your experiments?
At least in triplicate. You mean how many points?
Yes, yeah.
I guess around 10. And they were like spread within the whole interval. So I think it was sufficient to calculate these results.
Okay. 10 kinetic points you took for modeling.
Sorry, can you again?
You said that for kinetic modeling, you need at least, I don't know, 5-7 points, right?
Yes.
And you say you took around 10 points, right? 10 time points. And then if you model, your R square is 1, it means that your modeling is absolutely the same as your experimental points. Okay.
Thank you.
One of my last questions regarding the mechanism, if you can open the slide number, I guess not 21, before 21.
21?
19.
Tanara?
No, can we go maybe 19? No. Okay, this one, yes, 20. Not 20. Figure 15b. After absorption, before absorption, by this FTIR, you wanted to prove that you have some interactions, right?
Yes.
But I couldn't see any difference. And in the thesis, you provide some FTIR numbers, wavelengths, but we couldn't find it here in the figure. How can you prove that you have such interactions by looking at this FTIR, for example?
I guess the changes that you asked in thesis, they were to figure 1A. Yeah, and these numbers like 405, 880 that you asked for are here. Probably this was
be the same.
No, there is like we can see a little shift of some bonds, which tell about the change of length of the bonds And from literature, there is some data that when aluminosilicate framework reacts with big metal ions, it usually results in change in the length of this of the COC, CO aluminum peaks. Yes, they are like not very strongly shown, but still there are some changes in intensities and little shifts to like smaller region. So we conclude that there is some interaction.
Okay, but there is no any clear proof, right? I mean, just by small changes.
Like
to-
Plumbum or bond peak, like direct. So that's why we don't say that Plumbum or bond like is forming due chemisorption in this mechanism.
Okay. And the last questions regarding the BPA and PRO, slide number 23, 24. You said that ion exchange mechanism, ion exchange and physisorption, right?
Yes.
23.
23. Yeah.
Why in some cases you have the physisorption, in some cases ion exchange, but according to your nitrogen porosity results, you have, let's say, approximately the same surface area, the same material, but in some cases only ion exchange works, in some cases only physisorption. How it may happen?
Yeah, here these are results. Like here we try to apply the proposed model for another system studied here, and these are results of proposing this because model like method I propose can tell information about only ion exchange and physisorption. That's why like it is highlighted here, like and can make some confusion. But in case of bisphenol, like both sodium ions treatment and acid treatment decreased the absorption effectiveness, and we can conclude from here, like if according to proposed mechanism, yeah, in this framework, that ion exchange and physisorptions are not the mechanisms of interaction of our adsorbent with bisphenol A. But we used other information from other methods and like mechanisms that at first step of determination of mechanism, there is like we write the scheme and we evaluate all possible interaction sites in this system, in the studied adsorption system. So it's like theoretical estimation, and then we start find proof for each probable interaction type. And in this case, using a method that I propose, we could like tell that there is no ion exchange on physisorption, but other methods were proven by other methods, other interactions.
Okay. What is N here in the graphs? N plus. What is this?
It is a molecule of cationic surfactant, didoxyl dimethyl ammonium bromide. It is a quaternary ammonium compound, and the positive charge is due to this positive N molecule. It is like the structure of this compound, and I in this scheme like simply showed that the positive head contains this molecule.
Okay, but if
The
it's ammonium, you need to write as ammonium, not as a pure nitrogen, I think. Okay, still there is not 100% clear for me about the reaction
No, I mean
mechanism. Because,
not
for example,
It is in quaternary ammonium compounds. Ammonium hydrogen atoms are changed with the organic parts, and there is no like NH4. There are only N plus base due to some organic structures. So it is. It was presented and studied in
Okay.
literature. Yeah. Thank you.
Okay. All right. I think that's it. Most of the questions I put in the comments of your thesis.
Mhm.
I think there are more questions, and I think we don't have a lot of time to discuss all of them. Thank you.
Thank you very much.
Thank you, Bulat Nurlan.
Thank you. Akmaral, thank you for a nice presentation. I have several questions. Can you open slide 16?
Mhm.
1.6. So, okay, figure 12.
Mhm.
Yeah, so your points are somewhere far away from the lines.
Mhm.
Yeah, so I checked your dissertation, so you use some linear form of Langmuir isotherm.
Mhm.
Can there be an error? I think from what I see, there is some error in KL value. So in the like affinity constant or partitioning coefficient for Langmuir at for second, I think the same, because the the slope of this like initial part of this isotherm depends on the like distribution constant of this KL.
Mhm.
Can you explain that?
You mean that this model do not, in your opinion, this model do not fit well?
Yeah, definitely don't fit because the like slope at the experimental like line, let's say, and the like calculated lines with your like determined values of KL and Qmax. Yeah, so they are really different lines.
Mhm.
So I think, in my opinion, it seems like an error. Can you explain that?
We used a lot of models, and among these models, like at first, we assume that this is a Langmuir isotherm model by the type of experimental model, experimental isotherm, sorry. It looks like typical isotherm, Langmuir isotherm model, and R square of this model was quite high comparing to other models. But the thought model and other models are actually like were derived based on combination of Langmuir and Freundlich models, and their nature is like physical meaning is quite similar to them, but as I understood from literature, each model is derived to minimize errors. So here we just like chose models with the smallest error values, and it was thought model.
Okay, can you explain how you determined KL and QM values using the experimental results?
We determined it from equations.
Yeah, can you provide more details? How exactly, step by step?
It wasn't non-linear fit. It was, or it wasn't linear fit. It was non-linear fit, and we used Python to calculate them. So it, like using, like we put initial equations in that code, and it gave these values automatically. Because like making nonlinear calculations are very hard without any programs. Yeah, but in linear fit, I don't remember exact equation. Sorry, because I use so many of them. But it's usually from slope and intercept in nonlinear fit. But we didn't use nonlinear fit. Yeah.
Yeah, but it's very easy to use linear fit and the least squares method to
Yes,
determine intercept and slope using experimental results.
yeah, sure. But
So in my opinion, there is definitely an error because as you see from the results, so the slope, the initial part is completely different, you know, like maybe 2 times or maybe more. The difference is even higher in the slope of the first part between like 0 and 100. If you
Yeah.
put the linear line, so and you calculate the slope, it will be completely different, you know. So you didn't check this plot whether it fits? How exactly? So you cannot do it just but using the blindly using the code in Python because this is machine. It can have some errors. Yeah, so you need to like I don't know. From your answer, it's unclear for me.
Thank you very much.
Maybe the model fitting is correct, but the calculation of predicted values is wrong. You need to check, Akmaral. Professor Kenesov is right because you have 0.99 R square. Okay, and maybe Python gave you correct values, but then when you calculated the predicted and plotted here, you have a mistake. Okay.
Yeah. Thank you.
Yeah, it can be one possible choice is the wrong lines for Landmere and Toth, like some error in the figure. I don't know. I'm just guessing.
Thank you very much. But I guess none of the models can like be in like exact the same as experimental value. And here we also looked like the most important was Q maximum capacity, absorption capacity, QM obtained, and they were very close to experimental ones, because in experiment we have, I guess, 11.3, if I'm correct. I don't remember exact numbers. And here we have almost 11. And among used by us models, these models were the best fitted.
Yeah, there is no problem with QM. There is a problem with KL value. So, but the difference is huge. You know, you have 0.98, but what I see from the figure, it's much larger error. Yeah, so you need to check definitely. There is error either in the figure or in the calculations. So that's we need to find out. So if you provide the data, we can just it will take for 5 minutes to calculate and check. Okay, I have a second question. Table 8, can you show it? Okay, so you have E%, you know, the second column. So how can you get such small, are these standard deviation values or what, after plus minus? And if this is standard deviation, how could you achieve such small numbers and how exactly did you calculate them? That's my question.
Yeah. Thank you very much. Yes, we did experiments in triplicate and analyzed concentrations with atomic absorption spectroscopy, which gave concentration in 4 digits, like after 0. And when calculating using common, like first we calculate mean value, then in Russian, стандартное отклонение, sorry, in English. Yeah.
Yeah, okay, so these are standard deviation values, okay?
Yes.
But why do you say it's very accurate, but atomic absorption is not as accurate as you show in the figure. Yeah, so it's like 5% error relative. Yeah, but in this case, your standard deviations are like 1 or even 2 orders of magnitude lower.
Yeah, we did like separate experiment set exactly for this table. And we were very careful during our experiments, so probably that's why we get like such accurate results.
But can you show the data?
We didn't put it in thesis, just the calculation.
Okay, but
Like there is like huge amount of experiments done, and we thought that it would be better to like easier to understand if we in some parts didn't give like such detailed information. Not to overload
okay, but okay, I still don't think it's correct value. So I think they are from concentrations and somehow they appear at the same value here, which is completely different. But how did you calculate exactly this standard deviations for this E%?
I calculated in Excel. First, we calculated mean. We had 3 values, calculated mean values, then standard deviation, then used student coefficient. Alpha was 0.99, and then derived confidence interval. So this is confidence interval, sorry.
Okay, did you use E% or concentrations to calculate standard deviation?
E%.
So you get 3 E's,
Yes.
the values, 3 values of E, yeah, and then you calculate it. So you should get like 99.87, 99.89, something like that.
Yes.
So they were very close to each other.
Yes, they were very close, really.
Okay, it's really strange because these are like experimental error should be much higher. Even the reproducibility of atomic absorption is not as high as this. So it's like 0.01% like relative value. Okay.
Thank you.
Also the question about provision 1. So did you, actually Dr. Baimenov already mentioned that. Did you calculate significance of difference between values provided in the provision? Significance of differences, like null hypothesis testing.
Yes, in table, standard deviation are provided, but I didn't put them in provisions because I thought that provisions are already like big and quite difficult to read. So in order to make them simpler to understand, I thought that I would put mean values. So I rounded all first to integer values.
Sorry, my question was whether you calculated significance of difference. Can you show provision 1? Okay, you have 2 values, 616 and 624. Okay, did you check whether this difference is statistically significant? between these two values?
No.
Okay, thank you. And last question about the your absorption experiment. So you mainly use this batch, you call it batch
Yeah, batch.
absorption. Yeah,
Yes.
but why didn't you use like column chromatography or something like that for dynamic absorption?
Thank you very much. Yes, of course, dynamic absorption experiments are like better to apply in practice. But because the focus was on fundamental knowledge to obtain mechanisms, thermodynamic, kinetic data, usually batch results are used in these purposes. That's why we decided to put our focus on these experiments, because we have like several systems. So if we studied it all, like I would never finish this thesis. But of course, further, when we try to apply our obtained adsorbents in practice, it would be necessary to study column adsorption for sure.
Okay, but what about steering? Did you apply steering during the batch adsorption?
We applied steering around 200 rounds per minute.
Steering or agitation? Using magnetic stirrer or like shaker?
We
What
use
did
shaker.
you use? Okay, it's
No,
like
magnet.
agitation. It's
Sorry.
just agitation, yeah? Okay. But did you optimize the agitation before the experiments? Why did you choose 250 and such approach?
We studied that in literature for similar system, like most papers use this speed, so we applied it. We didn't study effect of agitation in this work.
Okay, I'm asking just because the diffusion in the liquid phase is very slow, and it can be a limiting stage during such processes. So okay, I understand that you didn't optimize. Okay, that's all from me. Thank you.
Thank you.
Thank you, Vlad Nurlanovich. Are there, do you have any questions? If you have no more questions, let me give the floor to the scientific supervisors. Silkhanova Guzia Mangildiyevna, Doctor of Physical Science, Professor of Department of Physical Chemistry, Catalysis and Petrochemistry, Al-Farabi Kazakh National University. Please, Guzia Mangildiyevna.
Здравствуйте, уважаемые члены диссертационного совета. Я буквально пару слов скажу на русском языке, извиняюсь, потому что официальный отзыв, в принципе, положительный. Мой, он находится в диссертационном совете, да, все там как положено. Конечно, я положительно отзываюсь о работе. Я хочу просто остановиться на нескольких таких моментах, которые, может быть, не отражены в этом отзыве, да, скажем так, а касаются каких-то отношений самой диссертантки и так далее. То есть вы сегодня увидели, Рахым Акмарал представила результаты своей научной деятельности, научной диссертации. И я думаю, ну, по крайней мере, я думаю, что вы увидели, что она понимает свою работу, разбирается в ней, теоретически подкованная, имеет хорошие практические навыки. Многие методы, все методы, которыми она, значит, пользовалась, она сама их освоила. Вот. И большое спасибо, конечно, в этом отношении также нашему зарубежному консультанту. В их лаборатории в Бар-Илане она сделала очень много тоже экспериментов, успела сделать до пандемии. Вот. И в то же время попала также на пандемийный период, но несмотря на все какие-то трудности, которые возникали, я считаю, что она достигла той цели диссертации, которую она ставила. Кроме того, я хочу сказать, что, конечно, исследования бывают фундаментальные, соответственно, прикладные. У нее, естественно, больше, скажем так, фундаментальные, ее диссертация относится больше к фундаментальным исследованиям, которые также сейчас являются такими актуальными, которые направлены на установление механизмов в таких сложных системах, потому что на самом деле у нее сложные процессы гетерогенные, да, протекающие на границе твердое, жидкое, да, получается. И такие исследования действительно не так много, их таких исследований. Поэтому была выбрана модельная такая более простая, скажем так, система, обоснованно, осознанно. Но я, наверное, не буду останавливаться на актуальности, новизне, значимости и так далее всей ее работы. Просто хочу сказать, что она очень ответственно относилась к своему исследованию. Вы видите, как она отвечала на вопросы, она буквально за каждую свою точку болеет. То есть она в любой ситуации, когда мы не раз обсуждали результаты, она всегда тоже старается отставить. Нет, вот так я повторила там 10 раз, где-то 3 раза, где-то еще больше. Ну, в общем, она, конечно, за каждую точку защищает свои результаты. Я думаю, что это было видно и по ответам на вопросы. Вот. И я хочу сказать, что, я не знаю, как я должна закончить. Я хочу сказать, что она достойна, считаю, что присуждения степени, если я могу такой вывод сделать как руководитель, я ее только с положительной стороны характеризую. Просто я хочу еще, как бы это не для того, чтобы как-то, чтобы вы тоже имели в виду, что она у нас молодая мама, 2 маленьких детей, и, соответственно, при всем при этом она все равно находит силы и возможности заниматься творческой деятельностью. Она творец, она уже, вы, наверное, видите, она достаточно самостоятельный такой, можно сказать, ученый, которая, скажем так, достаточно хорошо, скажем так, разбирается во всех этих теоретических, фундаментальных, аспектах именно физической химии. То, что касается термодинамики, мы видели, кинетики, да. Вот. Я положительно характеризую ее и, соответственно, как бы сказать, я считаю, что она достойна степени PhD по специальности именно химия, потому что у нее это и специальности есть. То есть как бы я, как еще раз сказала, что акцент делается в работе на фундаментальные какие-то, результаты, на фундаментальные исследования. Вот. Практическая значимость также имеет место, но в дальнейшем, как говорится, данная работа может являться каким-то базовым, скажем так, как вот фундаментом для дальнейшего продолжения исследований в этом направлении и уже доведения до каких-то реальных промышленных или коммерческих результатов. Спасибо за внимание. Всем большое спасибо. Хотела сказать еще большое спасибо рецензентам за очень детальные такие вопросы, которые они задали. Не то, что рецензентам, один из рецензентов выступал сейчас, Альжан, спасибо большое. Очень интересные вопросы, очень детальные, очень такие достаточно точечные. Спасибо всем членам диссертационного совета за проявленный интерес к нашей работе. Спасибо.
A little bit information. It was a local supervisor, Professor Silkhanova, and she characterized the applicant as an expert, and also she said that the work was more fundamental rather than applied. But this work can be, of course, used in the future for applied work as well. Also, she characterized the applicant like a really good worker, and the recommendation was positive. And in general, she recommended her for further award of the PhD.
Yes.
Thank you, Guzia Mangildivna. The next floor is given to Foreign Supervisor Mastai Itzhak, PhD Professor of Institute of Nanotechnology and Department of Chemistry, Bar Ilan University, Raman Israel.
Hello, good afternoon, everyone. First of all, I want to thank Akmaral for a very good presentation. Overall, Akmaral did a very important work. First of all, she had to do a work which combined two features. One is really experimental work, to characterize the material, to know all the physical chemistry of the technique she used, in parallel to advanced model of absorption. It's not common that one PhD student do everything, also calculation, also experimental work on zeolite. So from my own perspective, Akmaral was very good because she was able to bridge these two features which are not so common in a PhD student. Her work, it's actually a very interesting one because she explored the use of aluminosilicate material as absorptant. She used them for absorbing heavy metal and also organic metal. This work, it's fundamental work, but could be used for developing of many new applications like water purification, absorption of pollutant in water. All over, I think the work presented here and in her PhD, it's really worth. She deserves a PhD all over, I think. In addition, she published her work in a journal. I think she has a 3 international journal and more than that, a local journal and international conference. And I just want to thank her for the dedication, the time, and I have to also emphasize that during her PhD, she also became a mother, and she was able to bridge between being mother and a scientist and a PhD student, and she deserves the best mark if there is. So from my point of view, she did a good work. Regarding the comment and question asked during the thesis defense, some of the question really require again that Akmaral go into the data and improve it and correct it, because some of the question were really a very important one, which she have maybe to correct in the revision or in the final PhD thesis. Beside that, I thank her and I thank all you, the committee, and for attending her defense. Thank you.
Thank you, Professor Itzhak, for your opinion about our candidates. The floor is given to the first reviewers. Baymenov Aljan Ruldasovich, PhD, Associated Professor, Senior Researcher of Institute of Physics and Technologies at PAEF University, Almaty, Kazakhstan.
Okay. If it's permitted, I will not read all of my review, okay? It's okay. Just shortly.
Yeah. You can.
Yeah, in general, yes, the dissertation was carried out within the framework of the grant of the Ministry of Science and Higher Education of the Republic of Kazakhstan. In general, the significance and importance of the work is high. The self-reliance level of the candidate is high and is justified in the thesis. The overall content of the thesis is fully reflected, the topic of the dissertation, and all of the parts of the thesis is logically interconnected between all of these parts. About the scientific novelty, I put it as a partially new because this material, these zeolites and clay, are not very new. It was used for several decades for the absorption of heavy metals. But still, the modification with DDAB and SLES is a new one, I guess. But because all of the publication was done and published, I think the last one is to 2021. That's why I put the scientific novelty as partially new, because we don't know what was published during the last 5 years. The findings is new, partially new, also because I couldn't find the provision 2 real results. That's why I cannot say that's fully new. Actually, about the provisions, the provision 1 is, yes, is rather proven because the CES values was presented and so on. But provision 2, it's not fully justified. Okay, it was the publication in this direction, but as the thesis is not paper-based, as a thesis-based dissertation, that's why I think she had to put all of these results of the cadmium, strontium removal, and so on in the thesis, not as just in general as a provision that this percentage was removed and that's it, but no any proven graphs and results was provided in the thesis. The provision 3 is mostly proven, except of the some parts that are asked, for example, these FTIR graphs. Also, there is some minor changes, but it cannot be fully proven. You need to do another techniques like XPS and so on to have know the real mechanism of removal or absorption and so on. Let me go to the notes. It's 11. There are several issues. The provision 2 consists of the results of the cadmium, strontium, chromium removal, but the details of the results are not proven in the thesis. Why? Okay, but the candidate already replied to this question. Table 8, the total CES and the sodium zeolite is very close in standard deviation applied. Can you prove that results and are really different? It's also okay. The candidate has replied to this question. Page number 76 in the thesis, you provide the EDS data for iron, but it doesn't occur in the table 9. Also, why? Figure 18, why there is no any DDAB peaks in the DDAB zeolite? Figure 19, DDAB zeolite doesn't have any pure DDAB peaks. Also, why? Page number 83, no changes that are found in the SMZ spectrum after interaction with SLES. Then how to prove that the modification of zeolite by SLES was successful? You said that it's successful, but you write the opposite, that there is no any SLES spectrum. Table 13, why there is no any zeta potential values of sodium and H zeolite. Table 14, why did you provide particle size distribution in terms of area? It's also the question, why not present this in some diameter, radius, and so on in some numbers, not why it's in area. Table 16, some contradicting results. If we calculate the sodium CES in milligram per gram for table 15, then the CES is 3.8 it's milligrams of sodium per gram of clay. If you don't wrong, that means that 3.8 milligram was ion exchange removed from the 1 gram of clay, which is 3.8%, right? But in the EDS, you have 10 times less sodium content. The same is for zeolite. Any ideas why you have such contradictive data? Table 18, how do you know that 3 hours of experiment is enough for reach the equilibrium? No kinetics results were provided in the thesis. Chapter 334, there is no any kinetic graph and results, only applied models. Why not to present the kinetic graph itself? Table 12, how it's possible to have R square is 1. And table 26, most of the applied models, the sodium zeolite DDB Pro, have R square is 1. Please clarify how it was obtained. Most of these results was published in general in 14 publications. One is Q1 journal, one article in Q4 journal, 4 articles in scientific journals recommended by Committee for Quality assurance in the field of education and science of the Ministry of Republic of Kazakhstan. In general, the thesis and the work is good, but there are some questions that have to be solved before the degree of the PhD can be awarded. It is my own personal opinion. That's why I recommend to send the thesis to revision. And after the revision, the official award of the PhD can be awarded. Thank you so much.
Thank you, Ajan Ruldasovich. The floor is given to the applicant to respond to the reviewer's comment.
Thank you very much for such a detailed study of my work. So regarding comment number 1, that provision to consist of the results, but details are not given. Thank you for that comment. Because these data were previously conducted within the framework of my master's and the bachelor's projects, they were in publications. So to avoid self-plagiarism, we decided to put them as a summary table. At the same time, for the sake of completeness, we considered appropriate that we could briefly include this data, but pay more attention for new material. So this approach allowed us to provide a comprehensive scientific picture without violating ethical requirements for the originality and independence of the dissertation work. Regarding table 8, that total CC of zeolite and sodium zeolite are very close. As I answered you before, we should look inside the data, evaluating the cation exchange capacity of each metal, and pay more attention for sodium exchange numbers. And this value increases from 116 to 230, which is statistically significant. Comment number 3, Renata, can you please open slide? Да, после того, как заканчивается. In page 76, we provide data for ferrum, iron content, but it does not occur in table 9. As I checked, the data is presented in table 9 in the last column, and the numbers correspond to the ones given in the text. Next slide. Yes, here. So in the last column, the data of iron content are presented. Next, comments 4 and 5 are about that DDB peaks cannot be really seen in Raman and FTIR spectra. So this can be explained by small concentrations used, but to prove that modification was successful, we can also provide some CM images. And from our point of view, we can see that the coverage of surface of zeolite by film or amorphous particles of surfactants. And also to prove that modification was successful, we can rely on higher adsorption capacities towards materials that were not adsorbed by initial material. But after modification, adsorption occurred, it improved, and also can be as additional proof. Comment number 6, next slide, please. That no changes were found. Yes, probably the wording is not very successful here, but the review refers only the first part of the sentence, and the last part says that except for a decrease in the intensity of the peaks characteristic to the light water, and we like we consider these changes as that give information about interaction between surfactant and zeolite, also TM images, and as earlier, improved adsorption capacity. Next, table 13. Why there is no zeta potential values for sodium and H zeolites? Thank you for this comment. Yes, table 13 presents zeta potential value only for the natural zeolite, and the absence of corresponding data for modified samples may be noticeable. However, during the study, we performed instrumental analysis only when they were required to answer some research questions. In this case, the potential values of zeolite and clay were carried out in order to determine which of the two sorbents studied possessed more negatively charged in order to choose a system for a detailed study for determination of mechanism. And we considered that evaluating effects of sodium and acid treatment, the already done methods are sufficient. Number 8, why did you provide particle size distribution in terms of area? Yes, usually particle size distribution is provided by diameter, but as confirmed by CM and literature, natural aluminosilicates don't have they have different forms, each particle, and they are irregular shapes, non-spherical. That's why we thought that like using diameter in this case would give some wrong information. That's why we used areas. And how it was calculated, we used software ImageJ Fiji based on SEM micrographs and used area-based metrics. Comment number 9, that values of sodium from calculated from CEC are higher than from obtained by EDS method. Thank you for this detailed observation. This discrepancy is understandable, but it arises because these techniques measure different aspects of the material, so the results cannot be directly compared. Sodium CC values correspond to the amount of exchangeable sodium in all ion exchange sites of the material, while EDS measures only the surface total sodium, and it tends to underestimate light elements like sodium. And additionally, since zeolite and clay are of natural origin, they have the composition varies locally in these materials, and EDS measures the content like in some or only in some local areas that can lower sodium content. And there is some similar results can be found in different literature dedicated to study of natural materials. Table 80, comment 10 and 11 about that no kinetic data were provided. It is similar to the comment number 1 because we didn't provide detailed study on adsorption due to avoid unnecessary duplication of materials already presented before. But all kinetic data can be provided in publications. As example, some of them are shown on this slide. And due to the large volume of experimental material, we thought that like including all of these details would overload the dissertation, and we decided to place emphasis on not repeating raw kinetic data, but application of models and other new information. And comment number 12 and 13 about that R squared are equal to 1. In comment 12, it occurs because the experimental data points fit the model curve almost perfectly. The number of points was limited, but sufficient to obtain reliable results. And the data scatter was minimal, so the residual errors were close to 0. Under such conditions, the software calculates R squared equal to 1. And that in comment 13, that most of models for sodium Z plus DDV plus PRO system have R squared equal to 1. It can be understandable because those models are very close in their nature. They all were derived from Langmuir and Freundlich equations, but however, R squared was not the only parameter to evaluate the fit of model, because we also used error function analysis to choose the best fit model. So the combination of multiple fitting criteria provided a more robust evaluation of the adsorption models and justifies that the final choice of best fit model is correct in this work. Thank you very much.
Thank you, Akmaral. Dear Dr. Aljan Juldasovich, are you satisfied with candidates' answers?
Not fully satisfied, I mean, with the answers. Okay, she answered for all of my questions, but some of them is still right. Question number 1 about the provision 2. I don't have to go to the papers of the previous results to check if this cadmium strontium removal results was published and is it really proven? Because if you provide these results in the thesis, you have to provide, I mean, if you, as a provision, you have to provide it in a thesis. It's my opinion. Because how can I check if it's really was done, for example? And if you defend your thesis on the thesis-based defense, then you need to provide all of these graphs in the thesis. I think so. Maybe I'm wrong. Please correct me if I'm wrong. And some other questions also, for example, EDS. Yes, I understand. For example, question number 9. I understand that EDS is semi-quantitative analysis, and it doesn't show the real content, for example, of sodium. But if your EDS analysis is 10 times less than your ion exchange sodium, then I don't know, something strange. For the rest of the questions, yes, I'm satisfied.
Okay, thank you. Before the summary table that gives information about adsorption degrees, in the text we provided references to published materials, so it can be found there.
Yes, again, but I don't have to go to your papers and find this data. If your thesis is thesis-based, not paper-based, you have to provide all of this information in thesis. Why I have to go to your papers and try to find this information in the papers, not in the thesis. I think so.
Okay. Okay, thank you, Dr. Aljan Juldasovich. The floor is given to the second review. Turmanov Rakhymjan Ahmedkhanovich, PhD, Senior Researcher of Engineering Laboratory of Korkut-Ata, Kızıldağ University, Kızıldağ, Kazakhstan. Rakhymjan Ahmedkhanovich, please.
Thank you. Good afternoon, dear colleagues. The dissertation was carried out within the framework of scientific projects funded by the Ministry of Science and Higher Education of the Republic of Kazakhstan. The study contributes of solving tasks of outlined in state programs on ecology and sustainable environmental management as it aimed at creating efficient absorbent materials based on natural aluminosilicate for the extraction of toxic heavy metals and organic pollutants from aqueous media. The dissertation makes a significant contribution to the development of modern absorption science and environmental physical chemistry. The author has obtained new fundamental data on the physico-chemical behavior of natural and modified aluminosilicate solvents, determined the mechanisms of interaction between the solvents and the various classes of pollutants. The dissertation demonstrates a high-level independence in the execution of experimental work, data interpretation, and the formulation of scientific conclusions. The relevance of the dissertation is fully justified as the work addresses the urgent problem of removing toxic heavy metals and organic pollutants from water using effective natural aluminosilicate solvents. The content of the dissertation fully reflects its stated topic. All sections from the synthesis and the modification of aluminosilicate solvents to their physico-chemical characterization and the detailed absorption studies are directly aligned with the research aim of developing effective solvents for extraction of heavy metal ions, bisphenol A, and propanol from aqueous solutions. The purpose and the objectives of the dissertation fully correspond to its topic. All sections of the dissertation are logically connected, moving consistently from materials synthesis characterization and the absorption studies. The new methodological approach and the mechanistic interpretations proposed by others are well realized and supported by experimental data. The dissertation presents scientifically new results, including the first-time synthesis of aluminosilicate solvents modified with SLACE and the DDAB, and the newly proposed approach for evaluating absorption mechanisms. Provision 1, the first provision is sufficiently proven by the results of structural characterization and absorption experiments. Provision 2, the second provision is supported by detailed kinetic, isothermal, and thermodynamic analysis. Provision 2, the third provision is proven through comparative evaluation of different modification methods and their impact solvent performance. Notes on the thesis. First, lack a justification for the choice of error functions in the error function analysis section in the section table 6 lists the error functions used RMSE, SEE, ARE, MSE, and others. YU does not explain by what criteria the parameters were selected and what their advantages are in relation to the absorption models presented in the dissertation. There are also no discussion of the sensitivity of models to various error functions and how to use alternative metrics could affect the interpretation of the results, detailing the methodological grounds for choosing statistical tools would enhance the analytical rigor of their work. Second, lack of justification for the choice of hydrochloric acid for the activation of sorbents. The dissertation lacks a methodological justification for the choice of hydrochloric acid as an acid activation agent for zeolite and clay. The dissertation presents the results of treatment of sorbents with hydrochloric, but it does not specify why this reagent was preferred over other acids. In addition, in effect, various onions on the solvent structure, leaching mechanisms, and the material stability is not discussed. Adding a justification for the acid choice would increase the methodological transparency and the reproducibility of the study. 30. The issue of regenerization and the reuse of sorbents is not sufficiently disclosed, despite the fact absorption materials are positioned as practical and low cost. The dissertation lack on an analysis their stability during repeated use, data on desorption, structural changes after recycling, and the loss activity are not presented. This reduces the practical competence on the study. Fourth, the thermal stability of sorbents has not been studied experimentally. Despite the use highly concentrated solutions of acids and surfactants, the structural destruction of solid after acid treatment is discussed. However, the author does not perform TGA and DTG or other methods to assess the thermal stability and the stability of the samples. This is important because modifications change the solvent structure. The main results of the dissertation are presented in 14 publications. The dissertation demonstrates scientific novelty, methodological rigor, and the practical significance in the development and the characterization of modified aluminosilicate solvents for the removal of heavy metals and the organic pollutants from water. The main results are well substantiated by extensive experimental data supported by publications in high-ranking international journals and presented in a logically structured manner. The comments and the noted minor shortcomings do not affect the overall scientific quality or the validity of the conclusions. The author, Rakhym Akmaral deserves to award the degree of Doctor of Philosophy, PhD. Thank you very much.
Thank you, Dr. Rakhymjan Ahmedjanovich, for reviews. The floor is given to the applicant to respond to the reviewers' comments, please.
Thank you very much for such interesting questions. The first common lack of justification for the choice of error functions. Thank you for this valuable remark. Yes, we use several error functions to evaluate best fit of isotherm model, and each of this error function reflects a different aspect of model accuracy. Using several error function is a common practice in adsorption modeling because relying on a single criterion may lead to a biased interpretation. Different models may yield similar R-square values, but differ significantly in these errors. Although the dissertation does not discuss the sensitivity of each model to the selected error function, the choice of this matrix is consistent with widely accepted practices in adsorption studies. Their combined application enhances the statistical reliability of the modeling results and supports the conclusions regarding the fitting adsorption model. Question number 2, lack of justification for the choice of hydrochloric acid. Yes, the choice of hydrochloric acid as the modifying as activating agent for both zeolite and clay was based on several methodological and practical considerations. First, HCl is most commonly used acids in the activation of aluminosilicates. Numerous studies have demonstrated that hydrochloric acid effectively removes exchangeable cations and opens micropores without introducing additional polyatomic anions in the structure. And compared to other acids such as H2SO4, HNO3, or H3PO4, HCl has several advantages. The first, that chloride ions do not form insoluble precipitates with framework elements of aluminosilicates. HCl ensures clean leaching of non-framework cations without introducing strongly adsorbing or structurally complex anions. Chloride residues are easily washed out, and HCl is the most available acid in Kazakhstan, judging by low cost and the presence of producing industry in Pavlodar. And finally, the focus of this research was on evaluating the effects of acid-induced structural change rather than comparing different acid types. Therefore, selecting a single well-established acid allowed the study to remain methodologically focused and consistent. And for this reason, we chose hydrochloric acid. Comment number 3, that the issue of regeneration and reuse of adsorbents was not studied. Yes, I fully agree that studying the desorption process and adsorption-desorption cycles is important from both scientific and practical perspectives. In this work, preliminary desorption experiments were conducted for lead, cadmium, and strontium ions using SLS-modified zeolite. The results showed that desorption efficiency was below 5%, indicating a strong binding of the metal ions to the sorbent and consequently low potential for reuse. To increase desorption efficiency, more aggressive conditions would be required, and it could be associated with high energy consumption and significant water use. Therefore, an alternative approach is proposed in the study, the use of the developed sorbents in cascade stepwise processes of selective adsorption. Number 4, that TGA-DTG analysis was not performed. Yes, although the study involved modification of aluminosilicate using concentrated acids, the final sorbents were applied at relatively low temperatures, not exceeding 45 degrees. Therefore, we considered that thermal stability analyzing was not necessary for the purposes of this research. And the analyses such as XRD, Raman, and FTIR were performed, and they confirmed the stability of the main framework of zeolite and clay when using acid concentrations up to 3 mol per liter, which were used in adsorption experiments. Thank you.
Thank you, Akmaral. Dear Rakhmjan Ahmedkhanovich, are you satisfied with candidates' answers?
I agree. Thank you.
Thank you very much.
Thank you. Okay. Sit down, Akmaral. Dear colleagues, we proceed to the discussion of the dissertation.
So, dear colleagues, discussion, please, external dissertation council members, if you will say a few words. So we'll be very happy. Professor Stavros, Professor Helder, we will see if we just now the session for discussion.
So I can make intervention if needed. So we had this session where Akmaral presented her work. We read before the work. So as I said before, the work is very interesting. It goes to fundamental aspects. But when we asked about also practical aspects, Akmaral was able to answer clearly the questions. So there is, let's say, a long-term idea of what can be done in the progression of the results arising from this work. There was also some specific questions related with calculations done and other analysis taking from the results obtained. That was also very well answered. So there is maybe some need to revise some calculations that were pointed out during this session. But generally, in my opinion, this work is good enough to be awarded PhD to the degree to Akmaral. It's first time I am in this defense in Kazakhstan, so I don't know if in this phase of discussion is this appreciation that you were expecting, or if you need some more details, let's say.
Yeah, thank you, Helder. Because why we need this discussion session? Because the dissertation council, including reviewers, need to choose the decision. Yeah, that's why we and probably I will tell a little bit because actually this work is quite really comprehensive. A lot of work published. I was really surprised. 14 works, but one paper in a really good journal. This is a micropores and mesopores journal. It's a really quite journal. While the rest of papers, let's say in how to say, mostly in a local journal, which is for my opinion is quite short time, because the results will be enough to publish in a good journals. My question is why it was not possible to publish in an international peer-reviewed journal. Of course, a lot of questions raised during your defense. These thanks for reviewers for detail examination, detail analysis of your thesis. Yeah, and yeah, actually, during the defense, I analyzed also all these publications. It's quite a good work done. Yeah, so this is my opinion regarding the applicant. Thanks.
Well, if I can add, I may say that the volume of work is huge. So it's a document with 170 pages with many results, where the results were explained detailedly. So the mechanisms are very well supported by experimental data. It's not common. Sometimes there are works where mechanisms are made on assumptions, on hypotheses. Here they were supported by experimental analysis with several techniques. So the English used is very good. The candidate also did the defense in English with a very good English. So, in my opinion, the candidate has all conditions to be awarded the degree.
Thank you.
So if I may add something, I totally agree with Professor Gomez. And regarding the comment of the local journals, we have, the same problem because the country is trying to promote, local publishers and journals. So we are trying to balance between international quality journals, but at the same time to support this effort, So there is no perfect solution. To summarize, let's say the side of the reviewers who went through the thesis in detail, I believe that the second reviewer, Dr. Turmanov, is okay with the response from the PhD candidate. Dr. Baimenov raised some important issues regarding the availability of data. Personally, I don't have a problem if some of the results can be found, published in journals. My only concern, because during thesis, I believe that Akmaral mentioned something, is whether this published data coming before the PhD thesis. Because a PhD is a separate work, okay? But anyway, some work can be extended. Only this thing, if it was published before the start of the PhD thesis, there I might have an issue, okay? If not, I don't have a problem that the data can be found in another source because, okay, you can easily access them, yes, nowadays.
Yes, thank you. Most of the data, like my publications related to the thesis, start from 2018 till 2021. This is a period when I was like a doctorate student. So this was during PhD studies.
Okay then.
Okay, thank you, Doctor. Polat Nurlanovich, please.
Thank you. So what I would like to mention is that I checked the dissertation. It's really big. A lot of work was done, a lot of calculations, etc. Actually, I had these questions to figure 12 from the presentation, but somehow I didn't find this figure in the thesis. Maybe the supervisor or PhD student, Akmaral, maybe you can help me where this figure is. Is it really in the dissertation, this figure 12 in the thesis? Just one minor question. Just not to be wrong.
Which
Because
one? Could you show Professor Kenisov which one? Or
it's
say
figure 12 on the presentation.
Presentation.
Figure 12, just this difference between experimental and Langmuir was the error. So in the presentation, in the dissertation, I just didn't find it.
Figure 12. Probably no, it's not in this dissertation. I made it specially for presentations to be more like visually presented.
Okay, thank you for answering the question. I think we can close this slides. Okay, about the provision one. So as colleagues mentioned, and as I already asked, so it's not really proven, especially the first part, because the difference is definitely not statistically significant in the first two options. So because when it is mentioned that, just a second, I will read, that the treatment with sodium ions increases the cation exchange capacity of cell light from 616 to 624. But what we saw in the standard deviation, its difference is really not significant. So there is not really an increase. Yeah, so, and actually for other numbers, I think it should be okay. But also 129 to 104, there is decrease, but I'm not sure whether it's statistically significant too. Yeah, so it's like partially proven provision. So the second issue with this figure, I'm not sure whether it's correct. So just this figure is not related to the provision, so it should not be a big problem. But okay, so there is no need to revise this figure in the dissertation because it's not in the dissertation. Yeah, it was probably just for us. Yeah, but if it's an error in the figure, so it's not a problem with dissertation, probably. And what about other issues? So what I heard is that, okay, there are some comments from reviewer, Dr. Baymenov, yeah, so about the provisions and comments. So there is some probably issues with the provisions mainly, in my opinion. But I see definitely the problem in the provision one, so not in others directly. But we should take in this issue into the account when voting. Okay, but definitely the publication is very good. This mesoporous and microporous material. I think it was in the first quartile, the journal. Yeah, and the others are like, I agree that they could be published in better journals, but like theoretically, it's like doesn't these publications do not violate any requirements, etc. I believe they were peer-reviewed, probably. Okay, thank you. That's all from me.
Thank you, Bulat Nurlanovich. I think it's enough. Okay. We have to take part as a secret ballot. Yes. Bulat Nurlanovich.
Булат Нурланович, если можете, пожалуйста, проведите. So now the times for secret ballot. Құрметті әріптестер, қазір не голосование болады. So reviewers and the dissertation council, you will see the option in your screen. So just a few minutes, and we are now finalizing. Yeah.
Just a second, I need to find the poll because there are a lot of different polls. Just a second. And also I will move non-members of the council and the reviewers to the waiting room. So please do not disconnect. Okay, I found it.
Dear Helder, you will see the option in your screen. Just a few minutes, and in a few minutes you will see your option screen.
Okay.
Okay, just a second. I also need to connect from the second phone just to participate in the poll. Just a second. Окей. Булат Муратович, все, да, у нас? Is it everybody?
Да, it's all members. Just a moment, I need to check.
We have 9 people.
Yeah, all members is here, yeah.
So, okay, we are ready to launch the poll. Okay, just a second.
Раке, экранда не болу керек варианттар.
So just choose only one. Okay, we finished. Okay. Akmaral Muhambetovna, should I
Yes,
show
I'm.
the results?
Yes, the results of the secret online voting is 78% is what PhD of degree, and 22% sends the dissertation for revision. Based on the defense and the results of the secret online voting, the dissertation council at Al-Farabi Kazakh National University award the degree of Doctor of Philosophy PhD to Rakhym Akmaral Bakhtijan for the dissertation on the topic sorbents based on aluminosilicate raw materials for heavy metals, ions, bisphenol A, and propranolol extraction from aqueous solutions. Specialty 6D060600 chemistry. Akmaral, our congratulation, and dear scientific supervisors, our congratulation. Thank you all for participating in the defense.
Рахмет, құрметті әріптестер. Thank you for all, for your time, for all, for support. So thank you and see you next time.
Рахмет баршаңызға.
Спасибо за поддержку. Спасибо всем.
Друзья
Congratulations,
Мангельдиевна, наши
Akmaral.
поздравления.
Спасибо всем за поддержку.
Thank you
членам
very
дискуссии.